questions 49 through 54. A ball with moment of inertia equal to 2 mr squared over 5 is released from rest at the top of an incline of height h at an angle theta. There's no friction between the ball and the surface of the incline. The ball is still released from rest at the top of the incline, but this time there is friction. All right, so we're putting friction into this problem now between the ball and the incline. So the ball rolls down without slipping. What's the velocity of the ball at the bottom of the incline? So GPE, the total energy it starts with is all GPE, and that's going to be transformed into total kinetic energy. And since there's friction, the total kinetic energy is going to be two varieties: translational kinetic energy plus energy of rotation. So we have mgh equals 1/2 mv squared plus 1/2 all right, so let's see. Let's continue down on the bottom here. So we would have mgh equals 1/2 mv squared plus 1/2. Well, let's backtrack here. Since 1/2 is common to both of these terms, let's factor out the 1/2. mgh equals 1/2 times quantity mv squared plus moment of inertia times angular velocity squared. And then we could multiply both sides by 2 to get rid of the 1/2, and we would have 2 mgh equals mv squared plus moment of inertia angular velocity squared. Now we can plug in our moment of inertia. And angular velocity, so angular velocity is v over r. So we can, first of all, we could divide by masses. Oh, we've got the angular velocity squared. So we can divide by masses. And this angular velocity squared would be r squared times this squared and this r becomes squared, so these cancel, and we're left with v squared. So we have 2gh equals v squared plus 2/5 v squared. So v squared we're going to say is 1 times v squared, which is 5 over 5 v squared. So 5 over 5 v squared plus 2 over 5 v squared is 7 over 5 v squared. So to get v by itself, we multiply both sides by 5/7 and take the square root. So we have v equals square root of 5/7 times 2gh, which equals square root of 10gh over 7. See.